Welcome to Southeast Idaho, home of two sections of basin and range areas containing Paleozoic and Mesozoic marine sediments, brought to you by Chris Danker and Crystal Pierce. The main sedimentary rock types found in the basin and range area are Arkose sandstone, shale, oolitic sandstone, basalt, limestone, quartz sandstone, and even conglomerate. So what do all these marine sediments being in Idaho mean? How did they get there? Well, Idaho used to be under an ocean.
I got some oceanfront property
in western Idaho.
Okay, so this is how the whole Idaho story begins, with the marine sediments out there in southeastern part of the state. Began around 700 or so million years ago, a very long time, if you think about it, which you should, because that is a ridiculous amount of time. So again, 700 million years ago, the North American, or what would become the North American continent, was pretty small little place bobbing around in the equatorial regions. And yeah, here we go. Okay, so I just said 700 million years ago, but we're actually going back to 750 million years ago into the Neoproterozoic. Again, long time ago. What that essentially means, though, is that North American continent still in that bobbing around equatorial region. Idaho is right there on the coast, facing north. Lots of sediment being deposited either from the continent or out there in the ocean. So the early formations of limestone are happening, as well as sandstones, which are probably coming from rivers that are on the continent running north into those warm, beautiful waters. Most of the other continents are to the south and slowly starting to form the big Pangea supercontinent, which will come up here in a minute. So as time continues, we get down to around 540 million years ago. We're into the Cambrian, and this particular slide moves to the Devonian, which is around 370 or so million years ago. Generally speaking, the North American continent is still in that equatorial region. Again, Idaho's still kind of facing north. But again, you can kind of see from this slide that the area where present-day Idaho is was just nothing but beautiful tropical wonderland and warm waters. Life is starting to really move, or starting to happen at this point in time. And again, North America is still isolated. Nothing really going on with the other guys other than a big land formation to the south. Continuing with the sedimentary process, just lots of layering going on. Next slide, moving on up in the geologic timeline. We're so around 350 or so million years ago in this particular slide when Pangea has formed. Idaho still kind of hanging out where it has been for like 400 million years, which is insane. That's why you get these giant, super huge, thick packages of limestone out there in southeastern Idaho. So it just had tons of time to just build these deposits up and just get really, really huge. But at this point in time, Pangea has formed fully, and it's called a supercontinent. It's great. It's big. Again, great property for sale on the coast of Idaho. And yeah, it's still hanging out. But Pangea's formed. Mountains are popping up all over the place. We do have islands slowly starting to make their way towards the Idaho coast. So the good old days of the passive margin are slowly starting to end. So we're at 250 million years ago. This picture is actually from the Middle Permian, 275 million years ago. Had a lot of satellites back then, so it might be total BS, but we'll run with it. Probably looks pretty close. Anyway, as I digress, the island chains continuing to get closer. Modern North American features are slowly beginning to form, and here pretty quick, in another like 50 million years, the Atlantic Ocean is going to start forming. That's when the big changes really start happening in North America. But right now, again, sedimentary packages, that's the word of the day here in Idaho, where limestones keep on building. So hang on, it's going to get exciting. Okay, so here we are 200 million years ago, kind of cruising into the late Triassic and early Jurassic periods. Yeah, so this particular slide's starting to show the Atlantic Ocean forming. You got the island chains really starting to smear onto the western coast of North America. Pangaea is breaking up. Gondwana is forming. Gondwana is all that big old land masses to the south, which is Africa and South America, Antarctica, and all these other guys, where North America and Europe are part of Laurasia. So it's all starting to break apart. You got, again, like these island chains starting to impact Idaho. I don't know what they have against us, but they're coming in hot. And so they're starting to get subduction forming. And at this point in time, Idaho is beginning to be landlocked. And the good old days of the ocean views are slowly starting to end. So here we are at 150 million years ago, late Jurassic. North America is getting close to its present-day location. As you can see, the west coast is now a pretty mountainous region, where the east coast is the passive margin of the continent. The Atlantic Ocean is formed, but back out to the west, Idaho is completely landlocked, and all those marine packages are kind of where they are. They are not anywhere near the oceans anymore.
Present day, Idaho has seen a lot of action since its sedimentary days. The islands that were kind of sneaking up on us from the west side eventually did crash into us. This caused some mountain building, which caused our sedimentary rocks to uplift into their own little mountain ranges. The North American continent did move across the hot spot that is now located under Yellowstone. This cut a path across our mountain ranges and deposited some basalts into the borders of the basin and range regions. So since our sediments were uplifted into mountain ranges, what do you think's been happening? They're being eroded. When it rains, these eroded sediments flow down with the water into the valleys in between the mountains, which then form alluvial fans. So alluvial fans are really cool looking. However, they can be extremely dangerous because they are caused by that mudslide from the sediments draining from the mountains. Unfortunately, this can cause flash flooding if there's a populated area located nearby. Take Coachella Valley, California, for instance. It's tucked tightly between the San Bernardino Mountains and the Santa Rosa Mountains, and the photo to the right is an example of what that sediment drainage can do to a little town tucked in between mountains like that. Another danger with our sedimentary mountains are landslides. Looking back at our sedimentary rock types, we saw a lot of sandstone in our areas. Sandstone does have good porosity, which means that it can hold a good amount of water. If it's raining, though, it may not have as great permeability as we would like it. This can often cause the hillsides to become oversaturated with water. Those hillsides can't always remain stable anymore due to the oversaturation of water, and this will then cause the hillside to break loose and it'll slide down the mountain. Sometimes it isn't always very fast. It can move slowly, but then the other times it does end up going crashing down the mountain, and this can also cause flooding into populated areas. On the brighter side, since there's a lot of sand and gravel sediments being rinsed into the valleys in between the mountains, this means that the valleys are very porous and can hold lots of water, resulting in an aquifer. These valley-filled aquifers then supply the surrounding communities with their drinking water and water for their farming. Being marine sediments also means that some of our sediment was organic. This organic material was trapped and then eventually turned into natural gases and oil. These areas have been drilled dating back as early as 1903. Our southeast section of the Basin and Range area in Idaho is the second largest producer of phosphate in the nation. Phosphate is highly sought after and used in agriculture and industry. Another popular material mined here is limestone. Limestone is used for a variety of things. Its most popular use is for construction materials. It's crushed up and used as a road base and as aggregate in concrete. Another type of limestone called travertine is also mined here. The most popular uses are for tiles, for flooring, and countertops. Gold and silver has also been mined in these areas. It was most popularly mined back during the gold rush days. Unfortunately, this has left a ton of abandoned mines. These can be a hazard all their own as they are old and contain rotting wood, and if someone were to disturb these areas, they can potentially collapse and trap the person inside.